Good morning, all. Today we will discuss about Apriori algorithm. What is the main motto of Apriori algorithm is to find out the frequent item sets from the given data set. And second one is it will also generate the association rules. How to generate the association rules based on the support and confidence, and how to find the frequent item sets. So this is also based on the support and confidence. The main advantage of a priori algorithm is by using this algorithm you can generate more number of uh, frequent item sets. So let us discuss Apriori algorithm with some example. So let's see here. Here we have a data set. How many transactions we have? 9 transactions we have, and each transaction consists of 3 to 4 items like that. So first of all, what is the transaction width of each transaction? Let us consider T1 transaction here. So the transaction width of T100 is 1, 2, 3. So it consists of 3 items. So the transaction width is 3. Like that, we have to calculate the transaction width. In a priori algorithm, before calculating the frequent item sets, first you have to calculate the candidate item sets, and you have to fix the minimum support count also. So based on the minimum support, whether the support count of individual item or combo item or 3 item set satisfies the minimum support criteria or not. If the item set doesn't satisfy the minimum support criteria, it will be pruned from the frequent item set. That is the one of the main rule we have to follow by applying a priori algorithm on any data set. Let us consider. First, I want to calculate the uh, candidate item set. What I have to do, first you have to scan the database and identify the individual items we have in each and every transaction. If you observe that here we have I1 to I5, nothing but 5 items, unique items we have. In first step, you have to calculate the support count for each and individual item. How many items we have? 5 items. So we have to calculate the support count. So how to calculate the support count for I1, I will explain. So let's see here. So we have 9 transactions, and how to calculate, nothing but how many times the I1 item is repeated in different transactions. So let's see here, I1 is repeated in transaction 1, transaction 4, transaction 5, transaction 7, transaction 8, and transaction 9. So finally it is repeated 6 times. So the support count for I1 is 6. So remaining items also you have to calculate the support count uh, like that. And second one is, so before calculating the frequent item set, here L1 is the frequent item set. Like, but you have to put some items in the frequent item set. So first you have to compare the each individual item support count with the minimum support count. In this example, we fix the minimum support count is greater than or equal to 2, means if any item satisfy the minimum support criteria, nothing but I1 support count is 6. Yes, 6 is greater than or equal to 2. Yes, it is satisfied. So you can directly put those item set into the frequent item set. Okay, like that you have to you have to compare each and every item item support count with minimum support count. If the criteria is satisfied, you can directly put those items into the L1 frequent item set. So this is the first step to calculate the candidate item set. Next, frequent item set. Okay, for individual items, the candidate item set is designed, and the frequent item set is also designed. Then you have to make a combo, nothing but you have to prepare 2 items in the item set. Then forward by 3, 4, 5, like that. How many items we have? 5 items. So up to 5 items, we have to create the different item sets. Go to the next one. So based on the L1 frequent item set, you have to generate the C2 means candidate item set. Nothing but you can perform like different combos I1, I2, I1, I3, I1, I4, I1, I5. Next, I2 to combos I2, I3, I2, I4, I2, I5 like that. So we have prepared different combos the items it consists of only two items. Again, same procedure. You have to compare the support count of item set with minimum support count. Okay, here you have to apply the pruning. Why you have to apply the pruning? For example, I1 and I4 data set, I4 item set, the support count is 1. So it does not satisfy the minimum support criteria. One is less than or equal to 2. The support count is not satisfied. Simply you have to prune these item set, and whatever the item set satisfies the minimum support criteria, you have to put those items into L2 frequent item set. So here I have to prune I1, I4 item set and I3, I4 item set, I3, I5 item set and I4 item set. So you have to do like this. Next one is frequent L2 frequent item set is okay. Then we have to prepare the three item sets based on the L2. Yeah, let's see here. Here I have formed three item sets based on the L2 frequent item set. Here the main constraint is if you observe that in L2 we have more than two, more than three item sets here, nothing but number of item sets. But coming to C3 candidate item set, we have only two item sets and two item sets consist of three items. That is fine. So why the number of items are reduced means first you have to calculate whether these combo is satisfies the support count or not. Okay, I want to explain. Let's see this image. Here in L2 frequent item set, I have pruned some items from that. Why? Because these say item sets not satisfying the minimum support count. So based on this, then I want to prepare three item sets. For example, I am taking here I1, I2, I4. So you have to calculate the item support count for each two items. For example, I1, I2 support count is 4. Okay, it is satisfied. I2, I4 support count is 2. Okay, it is satisfied. I1 and I4 support count is 1. It is not satisfied. So you can't prepare this combo. Second, I1, I2, I3. So again you have to calculate the support count for two items. I1, I2 support count is 4. Okay, I2, I3 support count is 4. I1, I3 support count is also 4. These three items sets su- support the or satisfying the minimum support criteria. So this combo is possible. Nothing but you have to prepare different combos and each item set is eligible for the three item set or not. Nothing but eligible for the three combo item set or not. After doing a lot of calculations, finally we got I1, I2, I3 item set and I1, I2, I5 item set in the candidate item set. Okay, and after that again same procedure, you have to compare the support count of these item sets with minimum support count criteria. Okay, it is satisfied, you have to put those items into frequent item set L3. So if you observed in L3 we have only three items in the item set. So why don't we form I1, I2, I3, I4, four item sets, five items in the set. So it is not possible. Yes, you can do different calculations. For example, I want to form I1, I2, I3, I4. So I3, I4 support count is 0. So I can't prepare the 4 item set. For example, I want to prepare 5 items in the set. I1, I2, I3, I4, I5. If you observe I1, I5 support count is 0 and I3, I5 support count is 1. So 5 item set is also not possible. So based on this, the frequent item sets are I1, I2, I3 and I1, I2, I5. These are the two item sets. These are the frequent item sets. So in the first step, you have to build the candidate item set. and compare the support count of items with minimum support count. If the criteria is satisfied, you can put those items into frequent item sets. So that is the first step. And after that, you have to generate the rules. Why generate the rules? Apriori algorithm is used to find out the frequent item sets, and it will also generate the association rules. So based on the frequent item sets, we have two frequent item sets. Here I am taking only one frequent item set. How to calculate the, or how to form the association rule. So based on this item set, again you have to divide the item sets into different possibilities. So I1, I2, I1, I5, I2, I5, I1, I2, I5. So are the different subsets. Again you have to form the association rule. If you observe this association rule, I1 and I2, implication of I5. Nothing but the user already buyed I1 and I2. Or is there any possibility to buy I5 item along with I1 and I2? For that, you have to calculate the confidence. We already discussed the confidence formula. Again, I'm repeating. So here the confidence formula is sigma of I1 and I2 union I5 by sigma I1 and I2. So 2 by 4 equal to 50. So we are already discussed. So minimum support count is fixed by the user, like that. Minimum confidence also set by the user. So here I am taking 70% as the minimum confidence. So based on that, only three sets satisfy the minimum confidence level. I1, I5, I2, I2, I5, I1, I5, I1, I2. So these three sets satisfies the minimum confidence. So when you can say that it is a frequent item set, at the same time it is also satisfying the association boundaries. So definitely the item set must satisfy the minimum support criteria and minimum confidence criteria. So based on that, we can say that the items have strong association between them, like that. And coming to Apriori computational complexity of Apriori algorithm. What are the drawbacks of Apriori algorithm? We will discuss here. So computational complexity. For example, first one is choice of minimum support threshold. Means if you set the minimum support is very low value. For example, in previous example here we have taken minimum support count is 2. Okay, if I take minimum support count is 6, what will happen? So in the second step, in the third step, it will be stopped. But if you are taking a minimum support count is less, so you can generate more candidate item sets, you can generate more frequent item sets. Nothing but the generation of candidate item sets in the a priori algorithm is very slow. It takes too much of time to generate the candidate item sets. And second one is dimensionality. So if the number of items in the data set is increased, or it contain number of items, we have to generate a lot of candidate item sets and lot of frequent item sets. For that, we need a large database to generate candidate item sets and frequent item sets. That is also one of the computational complexity. And another one is size of the database. We need a huge database to perform a priori algorithm on any dataset. And average transaction width. In the beginning of that, we discussed it that what is transaction width of particular transaction. Let us consider T100 transaction width is 3. So if you limit the transaction width, like for example I want to take only the transactions it contain, transaction width is 3 2. So if you limit the transaction width, at that time also you can reduce the computational complexity. That is one of the advantages. But if you limit the transaction width, some necessary items may be missed. That is also drawback. At that time we can't get the perfect frequent items. So that is the one of the computational complexity of a priori algorithm. So coming, these are the computational complexities of a priori algorithm. So to overcome these disadvantages and computational complexities, we are we can follow the FP growth algorithm. So main difference between FP growth algorithm and Apriori algorithm is Apriori algorithm is mainly used for to generate the frequent item sets. That is, we know that, but it generate the candidate item sets. Based on the candidate item sets, it will generate the frequent item sets. But coming to FP growth algorithm, it will directly generate the frequent item sets based on the FP growth tree. In next video, we will discuss about it. Thank you.